Are you guys doing like dispensing snacks and gum? Is it gum? Who's the gum dispenser? Nice. Not a kid. Breath strips and then gum. Whoa. Sounds serious over here. I'm kind of I'm in as I am at the end of all these units, I get to like scroungy mode where I start looking at just let's clean up all the loose ends. So there's a couple loose ends we need to clean up. One of them two of them you're gonna learn today. It's not hard. And then there's one more that's going to be a little bit scarier, but once you realize how not hard it is, then we'll take the edge off that. And then we're ready to get to the end of this and move on to Unit 3. So I am working on a practice quiz. It might wind up being actually more than a practice quiz. It might wind up being more like a practice district assessment because it's got a lot on it, but it exists. I added some structure to it, and you'll get that here within the next couple days. But we're down to the end of this where what I always do is when we get to the end, I look at the district assessment and say, okay, what haven't we talked about? And that kind of guides my instruction for the last week or so. So hence today's lesson. Okay, so the first thing we're going to do what's today, the third? Um, the first part of this lesson is not going to take longer, I hope, than like 5 minutes. And we're going to be evaluating exponential functions. So you learned back in Algebra 1, and I don't know if we did it in Algebra 2 or not, but you learned how to just generally evaluate functions. So let me give you a simple sort of Algebra 1y example before we get into the exponentials. So in Algebra 1, I would have given you a function like this, and I would have said, okay, f of x equals x squared plus 5x minus 12. And what I would have asked you to do to evaluate the function is I would have said in this language, I would have said to, oh my, little rogue symbol there. Did you see it? I would have said to find something like, let's do f of -3. Do you guys all remember what that lingo means? Yeah. So basically every function, like this thing that I'm underlining in red is just like a monster just waiting for you to feed it. And when you evaluate a function, like Bryn said, you just feed the inputs. So it means you feed a -3 into where the yellow arrows are pointing, right? And again, it's been a while since we've ever explicitly like really done this in this language, but the math turns out to be not all that bad, right? So like if I know what I'm doing, if I put -3 in for x, what's -3 squared? 9. And then if I put -3 in the second yellow arrow, what's plus 5 times -3? Yeah, I'll just call it a minus 15 and then minus 12. And then what's 9 minus 15? And what's -6 minus 12? So we say that f of -3 equals -18. Okay. So we spent at least probably a couple of days at some point in our pasts together practicing that skill. That's called evaluating a function, right? And so today we're going to do it with just slightly more complex functions, but the math really isn't all that bad, provided that you know some basic things. Like, do you guys know what 5 to the -2nd power is? The common wrong answer is -25, right? What if I told you that the answer was 1 over positive 25? Does that ring any bells? Remember that when something has a negative exponent, you don't make it negative, you flip it over, you reciprocate it. So you're going to be seeing a lot of negative exponents throughout the assignment today. And when you do, just remember that it doesn't have any control over whether the answer is positive or negative. It just causes things to move. So like if you need a little more explanation, this 5 was quite literally picked up and placed into the bottom. So before the answer looked like that, in its sort of intermediary stage, it looked like that. The 5 to the tooth just got moved downstairs and the exponent was made to be positive. So, all right. So having said all of that, this should not be a problem. I've only got a couple of examples for this portion because you're not going to struggle here. So let's say we have a function called g of n. So g is a function of n. That means it eats n's. It says feed me n's. And the function rule is 3 to the power of 2n minus 2. And I ask you to find g of -1. So just don't ever lose sight of what it means to evaluate a function. It just means to feed -1 wherever there's an input slot. Some functions have more than one input slot. This particular function only has one, and it's right where that arrow is pointing. So we're going to take the -1, the feeder, and we're going to put it in there. And what's the exponent going to become? It's going to become -2 because that's 2 times n, which is 2 times -1, which is -2. So the worky stage of this problem is to take 3 now to the power of -2 minus 2. And what is 3 to the power of -2? 1/9. And how do we do 1/9 minus 2? Yeah, I would. Right. So I would take 2 and quit calling audible and say, hold on. I know that you're 2, but I know you also is 18/9. You still equal 2, but now you play nice with the homie over there. And what's 1/9 minus 18/9? So we say that g of -1 equals -17/9. So obviously it's a little bit more intensive on the math side of things, but like I advertised, if you're good with your basics, there's really not a lot of meat on that bone. Let's try another one. Okay. So here we have a function named f. He is a function of x's. He says, feed me x's. And we have the opposite of 4 to the power of x plus 3. And we're going to find f of 0. So our feeding slot is right there. This particular function only has one. I think most of the problems in this section that you're going to see on your assignment, all of them, they only have one feeding slot. So you'll just have to replace one letter with a number. So if I replace that x with a 0, the working stage of this says -4 to the 0 plus 3. So what happens now? What do we do first?
Like, isn't that like one?
Yeah, one of the most common misconceptions that people have, like if I were to put this on a test, the most common wrong answer that I would get would be 4. Because we just assume that this is -4 to the power of 0. And you do know that anything to the power of 0 is 1, right? You know that. The trouble with this answer and our erroneous sort of thought process here is what actually is being raised to the power of 0? Just the 4. Remember, if I wanted the negative to be part of it, then I would have put it in parentheses. So the purple jelly bean will speak the truth. The purple jelly bean says, only I, 4, am being raised to the power of 0. And what is 4 to the power of 0? It is 1. And then that negative says, don't forget about me. It's just simple order of operations. I'm not making stuff up here. Okay. The negative is like a multiplication problem. Exponents go before multiplication. And now what is -1 plus 3? So that's how we would approach that. I could come up with a handful more, but honestly, you'll just learn the ins and outs of this as you go through the first half of the homework.
So,
Yep.
that make it like
Right. So if I wanted it, so if I wanted -4 all to go to the x, then I would have written the problem like this.
Okay.
Do you see? Because now -4, the whole quantity is being raised to the 0. And if the whole thing goes to the 0, then the negative gets gobbled up in the exponentiation process. Got it? Better?
Yep.
Okay. The second half of this is something that I think we've done before, but this particular approach I know is on the district assessment, so I wanted to take and knock this out today. So we're going to be doing some compositions. And these are algebra heavy compositions. So if you're good with things like square, square, multiply, double, and distribution and all that, like if algebra generally doesn't give you grief, you'll not struggle with this. So I have a couple of examples for this. And a couple of these I might just make up as I go. But what happens with compositions is I give you one function. There's a function named f, and his job is to take whatever you give him and add 5. And then we have another function named g, and he takes whatever you give him, squares it, subtracts 4 times whatever you give him, and then adds 2. So we have two functions working in tandem here. And this this lesson today has nothing to do with inverses or anything like we've been talking about. So this is just some stuff we got to get off our to-do list. So there are several compositions that we could do. There are four of them to be exact. One of them, the simplest one, is to do f of g of x. You've seen this language before. Do you remember when we did it to verify that two functions were inverses of each other? So mechanically, it's not a brand new process for you. Like you've seen the lingo, f of g, you've heard it, f of g of x. You'll also see it sometimes written like on a different test, like a standardized test. You might see f of g of x written like this, f of g of x. I don't like that language. I don't like those little circles, how they look like O's. So I elect to always use the purple notation, but I just wanted you to be aware that if you see those little risen sort of smaller circles that look like little mini donuts, that's another way to say composition. I elect, though, not to use it. So you'll see mine like this. Good. So this is the simplest one that I could think of to start us with, f of g of x. So does anyone know how to even get this process started? That is what you do, right? So we take this function g and we plug it quite literally into where that arrow is pointing right there. For me, as I worked through these, when I was kind of playing around with them last night, what works for me, if you want a strategy, is to take the first one you see, f, the outside function, and do the function, but write a blank space wherever x would be. So for me, I say, okay, so it's x plus 5. Do you see how I did that? I'm just like saying I'm leaving that slot open for feeding. And then what am I going to put in that blank? X squared minus 4x plus 2. And these parentheses obviously serve no purpose mathematically. They were just there sort of for visual effect for you. So this is a super simple problem. So if I combine some like terms, I wind up just real simple with x squared minus 4x plus 7. Math doesn't get any easier than that. On the other hand, though, if we reverse the composition, the difficulty level goes up a little bit because let's say instead of composing f with g, we compose g with f. Can you see why that's going to pose a problem? Let's take a look at it. It's much more complex. If I do g of f of x, oh boy, watch out. The got rougher. So here I go. I'm going to write the outside function g, but every time I get to a place that says x, I'm going to leave an awkward void like this. I'm going to go x squared minus 4x plus 2. And what's going to go in those awkward voids? X plus 5, the f function, this one. So we put that there, and we put that there. And this is the kind of algebra that you're going to find yourself wrapped up in here today. So let's talk about this first, the red oval. You guys remember how to do that?
Excellent.
So proud when you say stuff like that. Yes. If you're not sure how Blair or myself got that, remember it's just x plus 5 times x plus 5. You can go through and do the whole multiplication or make your math teacher super proud and do square, square, multiply, double. So, but that's what that comes out to be. You'll be doing a lot of that. And then how about the green egg? What is the green egg going to be? It's just distribution. So what do we get? Right. And then, of course, you've got the leftover guy, the constant from the function that was unaffected by the substitution. And then from here, it's just combination of like terms. So x squared, and then how many x's? Plus positive 6x, and then a whole bunch of constants. What's 25 minus 20? 5 plus 2, 7. So that's just a real little, obviously harder than the first one. And then the final thing I wanted to say about this is we can sometimes have to do self-compositions. And I don't want this lesson to take too much longer, so I am quite frankly going to cut it off after this, but I wanted you to see that functions can be composed with themselves. So another example of a composition, and I'll do the simple one first, is you might actually see, not might, but you will see this. And this happens in the real world, like if a process like a discount or any sort of numerical sort of something that affects a quantity or a value, if it gets repeated, like a 20% coupon, and then you have another 20% off of that coupon, that would be an example of like a composition, a repetitive composition. So when we do f of x, it's just the same kind of speech. You take f of x and put, x plus 5, right? Except what do we put into the blank? X plus 5. You're actually substituting a function into itself and getting x plus 10. Simple. Again, obviously, goes without saying, but I always say things that go without saying. Doing G composing with himself is going to be infinitely more difficult just because of the quadratic nature. So, but the key to be good at this, I think, is just like I said, the patient sort of setup, and that is to just start with the outer function G, and you write blank squared minus 4 blank plus 2. But this is the poopy part. What's going to go in there?
X squared minus 4x.
Right. X squared minus 4x plus 2, and then x squared minus 4x plus 2. Everything in the red box is beneath you. That is 8th or ninth grade difficulty at worst. So that's not a concern. That's just low-level distribution. It's the other stuff that can get a little bit gnarly. So we don't really have a square multiply double trick for something like the white stuff. And so we're just going to go old school and roll up our sleeves and get our hands dirty, choose whatever stupid saying you want. But here it goes. When you square something like this, it's going to be x squared minus 4x plus 2 times another x squared minus 4x plus 2. Sometimes there are no shortcuts. How many multiplication problems are we about to have to do? Try again. 9. Yes, because to get through a trinomial times a trinomial, you have to take the x squared and let him do his 3 jobs. And then you have to take the negative 4x and let him do his 3 jobs. And then, of course, finally, you have to take the 2 and let him do his 3 jobs. So you wind up having to triple multiply everything. So it's sort of a PETA. Would you like to finish this? No? Yes? Let's get her done. So what's our first red answer going to be? Yeah, got my colors. Good job. X to the 4th. Second red answer. Third red answer. Dope. Okay, let's head on to the purples. What's our first purple answer? Yes. And note as you look at the television where I'm writing that, I'm electing on more complex problems like this to combine, not combine, but arrange my like terms. That's very much on purpose. What's second purple answer?
16x.
So plus 16x squared, last purple answer. Yeah, and let's get on to the yellows. What's our first yellow?
2x.
So plus 2x squared, second
Minus
yellow, minus 8x, and plus 4. If you arrange like terms in a pattern like this, it can just help you at the end of the day just to get her done. So that's that. And then you just add downwards, and I guess I'll use white since I haven't used white. So your answers are going to just come from adding like terms. How many x cubes are we going to get? How many quadratic terms are we going to get? 20? Linear terms? Yep. And constant term? Good. And don't forget that that's not actually the end of the problem. So that's just that one part of it. So that is the part up here that was not in the red box, right? But if I take now, let me see if I can grab this. I don't know if the computer will like this or not, but if I can move this down, oh, that's slick. Yeah, look at that. See if I can just move that down and I'll just cheat and place it right next to its buddy right here. Ooh, he's so fancy. So let's distribute. What do we get when we do the red box distribution?
Negative 4 squared plus 16x minus 8 plus 2.
And then finally, it's time to combine some darn like terms. That was a lot. There's a lot of meat on that bone. Not all problems are created equal. So what do we wind up with?
64
Mhm. Yep.
plus 16x squared. Plus 2.
Nice job. So what happens is this, I'm gonna use purple, I suppose, to draw your attention. That minus 16x that came from that demon problem, and this plus 16x that came from our 7th grade distribution, those just cancel each other out. So we can skip right over the linear term. Then we wind up with 4 minus 8 is negative 4 plus 2 minus 2. And that concludes. I could just keep going, but I don't want to, and you don't want me to. So front half of the worksheet is evaluation. Back half of the worksheet is composition. And we'll do this for probably today. I don't know if we'll do it tomorrow, but we'll see. So work hard for 20 minutes and we'll see where you're at. 21 minutes. Oh, I got to pause this. Sometimes I forget.
That's-
Okay, so are we doing this number 13? Yes.
I know how to go through it. I already started.
Right.
It's a free answer.
Kinda, but not really. Not one that's ready yet. So give me a little bit. So we're doing G of F of it. How about can we change them to X's? Are you okay with that? Yes. Sorry about the T. Yeah, T's are no good. So G of F of X. So that's going to be 3 input squared plus 4. And in the input, we're going to put F, which is 4x squared minus 3. So job 1 is to do this red box first. Make sure you leave that 3 out. Make sure you leave the 3 out, right? Because it's not part of this. You have to square, multiply, double first.
Okay.
So what is our first answer going to be in the red box? Nice. T squared, right? Nice. I love it. And then at the back.
Plus 9. Okay.
Of course, you can anything in parentheses, anything that's a binomial squared can be square multiplied double.
So, you be the partner and you do.
Anything. But it has to be a binomial. If there's more, like you saw in the lesson today, if there's more than 2 terms in here, then the algorithm, the square multiplied double doesn't have any meaning. Got it? And then we got a plus 9 at the back, right?
And then we multiply 3.
So what do we get?
Oh, God.
I'll be 48 x to the 4th minus 72 x squared plus 31, and we are done. Because I got 27 plus 4, right?
Yeah.
There you go.
I didn't bring my calculator with me.
You're fine. All right, I'm going to end the recording. So I think that's all. Look at that, the bell.